Hi, I am going to discuss about common gate amplifier with small signal analysis. In common gate amplifier, the gate is common for both input and output side. So we know that the symbol for MOSFET common gate. So this is an gate terminal, and this is an source and gate, and this is the drain terminal. If the gate is common for both input and output, so then it is named as common gate amplifier. So I am assuming here it is an input signal, and this side across the gate and source, gate and drain, we are taking the output. The main function for the amplifier, we know that while giving the small signal, it amplifies the given input signal. Every amplifier is having a particular frequency range to amplify the given input signal. At low frequency you may get the distortion, at the high frequency range you may get the distortion. So this is every amplifier is having particular frequency range bandwidth to amplify the given input signal. Biasing resistors, and we can set the Q point and get the output without any distortion. Coming to the small signal analysis, we can see this. By using small signal analysis, we can find the input impedance of the circuit and output impedance of the circuit. What is the voltage gain? What is the current gain? So these all parameters we can calculate mathematical analysis by using small signal analysis. I will draw the small signal analysis. For this, we can say this: the transistor is in between output and input. So here the gate is common for input as well as the output side. So here we can assume that you can say this transistor is in between. I am drawing here. So first we need to draw the equivalent current for transistor. This is in between input and output side. So that's why I am writing here GM multiplied with VGS. That is an IDS. Why? Because GM means transconductance. GM multiplied with VGS means transconductance output current by input voltage VGS multiplied with VGS. VGS cancel, only IDS is there. So that is the current equivalent. And coming to the input side, we can see this: we are giving the input here. Across the source we are giving the input. So input side, the resistance is only one is there. So we need to draw this, the input side. This is RS. Input side RS. And coming to the output side, RD is there, RD, and RL is there. We can see this in the circuit. You can observe this right side, RD is there, RL is there, and both are in parallel, not in series. Both are in parallel. You can assume that, you can see that. So that's why coming to the output side, I am writing that is RD, either small RD or capital RD we can write. So I am writing here RL. So this is the equivalent circuit for the small signal analysis. Transistor is in between, and input resistance is only RS is there, input side. And coming to the output side, there are two resistances, RD and RL. So therefore we can write it here. So this is an input impedance, ZI symbol. I am assuming this is an output impedance. This is an output impedance, Z0 symbol. Now we need to calculate what is an input impedance and output impedance. Coming to the input resistance, what is an input resistance? Ri equal to, only one is there, RS, either small RS or capital RS we can assume. So RS, only one is there. And coming to the output side, what is an output resistance? RS0 equal RD parallel to RL. RD parallel to RL. Or else you can assume that RD multiplied with RL divided by RD plus RL. So this is an output impedance. This is an output impedance. Coming to the input impedance, Zi equal input voltage by input current, or else input voltage equal input current into input resistance by input current, cancel, and Ri. So therefore, but we know that Ri equal to Rs. So this is an input impedance we are calculated mathematically. For the given circuit, the input impedance is Rs. Coming to the output impedance, Z0 equal output impedance Z0 equal output voltage by output current I0. V0 equal, we can write it as I0 into R0 by I0 cancel, and remaining is R0. But R0 equal to, already we are calculated, only RD parallel to RL is the resistance, output resistance. Therefore, this is equal RD parallel to RL. So this is the output impedance. Coming to the voltage gain is equal output voltage by input voltage is the voltage gain, we can write it. But V0 equal I0 into R0 by II into Ri, we can write it. But I0 into II can be written as current gain and multiplied with R0 by Ri. We can substitute R0 and Ri values. R0 is RD parallel to RL by Ri is Rs. So like this we can find the any circuit voltage gain, current gain, or else what is the impedance, input resistance for the circuit, output resistance, output impedance for the circuit. Mathematically we can easily calculate. Thank you.